Hello everyone. As we discussed earlier, the Ohm's law, here we discussed Kirchhoff's law, that is Kirchhoff's voltage law and Kirchhoff's current law. Now come to the Kirchhoff's law. Kirchhoff's given two laws. One is Kirchhoff's first law, other one is Kirchhoff's second law. Kirchhoff's first law is Kirchhoff's current law. It is also known as junction law. So Kirchhoff's current law is used for current. For this, if we see a circuit, in any circuit there is a node. Node means there is more than one branches connected into the point. So if you see the diagram, there are 5 branches, 1, 2, 3, 4, 5 that are connected at a point. That point is known as node. So if you see, there are 5 branches. One is I1 current, I2 current, I3 current, I4 current and I5 currents. I1, I2, I3 are incoming currents and I4, I5 are the outgoing current. So the Kirchhoff's current law states that the algebraic sum of currents at any node at any instant is 0. So if you see this law, so I1 having, if you see I1 plus I2 plus I3 and minus I4 minus I5 is equals to 0. For applying this law, we assume that incoming current has positive polarity and outgoing current have negative polarity, and we sum all these currents, and the sum of all these current is equals to 0, or you can say incoming current is equals to outgoing current. So this is a Kirchhoff's current law. We applied it into the circuit for analysis of a circuit. Now come to the Kirchhoff's second law, that is known as Kirchhoff's voltage law. It states that the algebraic sum of all the voltage around a closed path at any instant is 0. So if you see a circuit in which there is a source voltage V1 and there is some elements having voltage V2, V3 and V4. You can connect any n number of any elements having voltage V1, V2, V3 to Vn. So basically the algebraic sum of all these voltage is equals to 0. That given by Kirchhoff's voltage law. That means summation of voltage is equals to 0. So in this particular circuit, if we apply the Kirchhoff's voltage law, we have to know some basics. So if we see a battery or a voltage source between a terminal A to B, you can connect a battery between terminal A and B like this. A connected to positive terminal or B connected to negative terminal, or you can connect like this: A connected to negative terminal and B connected to positive terminal. So you can say, if we see the voltage from A to B, if we select a path from A to B, then voltage V is equals to minus E, that is fall in voltage. We go from plus to minus, that means drop in voltage. For this we use a path A to B, then the voltage will be minus E. Or if you see this, then next battery in which we are going A to B, then the output voltage V is equals to plus E. or you can say we are going from A to B, that means negative terminal to positive terminal. You will say there is a rise in voltage. So if there is a rise in voltage, then voltage will be plus E. If you understand this point, then we will apply Kirchhoff's voltage law in this circuit. So if you see the circuit, and there is some point, that is A, B, C and D, and there is a closed path A, B, C, D and A. So if you say start from point A and end to a point A, from A to B, for path A to B, voltage will be rise in voltage, then you can say plus V1. Okay, you can write plus V1. From B to C, there is fall in voltage, so you can write minus V2. From C to D, plus to minus, that is fall in voltage, that is minus V3. From D to A, again fall in voltage, that is minus V4 is equals to 0. So you can say V1 minus V2 minus V3 minus V4 is equals to 0. So basically the basic concept for applying a Kirchhoff voltage law, you have to select a path in which current is flowing through it, and for the batteries or for the voltage source, we see a path from negative to positive terminal, there is rise in voltage, and if you see a path from negative to positive voltage, there is rise in voltage, so positive voltage, and if the fall in voltage, then negative voltage. And if you see the circuit element resistor, current always flow from higher potential to lower potential, and if we see a current direction, then one terminal is positive and other terminal is negative. So for applying a KVL, you have to assume the polarity of the circuit element, then we will apply a Kirchhoff's voltage law, and it is very easy to write the KVL equation. As we see the Kirchhoff's law, Kcl is known as conservation of charge and KVL is known as conservation of energy. In Kcl, we see Kirchhoff's current law. Current is flowing at a node. For flowing that current, Q is flowing into the terminal, and if we see at a node, all the currents are flowing in a node, Q is flowing into a node, that means there is no loss of charge if the incoming charge is equals to outgoing charge. That is also known as conservation of charge. So net charge accumulation is equals to 0. Now come to the KVL. It is also known as conservation of energy. In KVL, we applied voltage, or you can say the algebraic sum of all the voltage in a closed path is equals to 0. For applying this voltage, I current will flow, and this I current will provide by a charge Q. So you can say V is equals to W by Q, that is for Q coulomb. To transferring a Q coulomb charge, we have to work done by W. So if we apply the volt KVL, then for Q coulomb charge to move into a closed path, the net work done is equals to 0. That is known as conservation of energy. For circuit analysis, we have to follow two methods. One is mesh analysis or loop analysis, other one is nodal analysis. In mesh analysis, we apply Kirchhoff's voltage law, and in nodal analysis we apply Kirchhoff's current law. Thank you for watching the concept. Please like and subscribe my channel.